Here's part 2 of the video for this example for y equals cosine of 2x minus pi. In part 1 we found we accomplished all the horizontal transformations for the graph by solving this inequality, and I talked a little about why you'd solve that inequality to come up with this one. So now we know that one complete cycle for this graph will occur as x ranges from pi over 2 to 3 pi over 2. Now, as far as actually graphing, so I'm going to back up once more, and consider the graph of just plain old cosine of x. So you'd want to be very familiar with that graph to start with. Now the shape for the typical cycle that we draw for cosine, it starts and ends at its maximum value of 1. And if it's cosine of just x, then we're talking about the interval as x ranges from 0 to 2 pi. Okay, but so right now I want to focus on y values. So it starts and ends at that maximum value at 1. Right in the middle, so we could just draw a little hash mark representing the middle there, it reaches its minimum value of -1. Okay, and then halfway between this maximum value and this minimum value, it's going to have an x-intercept right here. And also on the right-hand side of the graph, halfway between this minimum value and this maximum, there's going to be another x-intercept. So again, we could just mark the halfway point here and draw an x-intercept. And so here's the basic shape for the graph of one cycle of y equals cosine of x. Now what we want to graph is y equals cosine of 2x minus pi. We already know, let me just go ahead and mark 1 and -1. We know there are not any vertical transformations because there's nothing going on outside of that cosine function. Any of the transformations in this graph all are based on what's going on inside of the function, which that's going to be horizontal transformations, and those are automatically taken care of when you do this part 1 of the video, when you solve this inequality. So now we just have to go with the information that we found. So we know that the complete cycle is going to start when x is, my writing tool, when x is pi over 2. And I didn't mean to make that. I'm going to just stick with it because I don't see a quick way to change the thickness there. Okay, so pi over 2, I'm going to call this 2 pi over 2, but I'm not going to label it. And so this would be 3 pi over 2 right here. Okay, and then I guess I'll use blue to actually graph. All right, so now plotting points the same way we plotted points over here. So it starts and ends at its maximum y value of 1. And we know that our cycle is going to start at pi over 2 and end at 3 pi over 2. So we've got these 2 points. Right in the middle, it's going to reach this minimum value of -1. And so we can just judge the middle based on, we've got 2 spaces here, so the middle dash there. You don't have to label every single x value, by the way. It's fine if you just label your starting and ending x values like I have here, and then just draw little hash marks to represent the other important values. Okay, so now halfway between this maximum value and the minimum value, I'm going to have an x-intercept right here. And on the right-hand side, halfway between that minimum and the maximum, I have an x-intercept here. And then that's the graph. And that's it. So that's why starting by solving that inequality like we did in part 1 makes drawing the graph so much easier. That's going to be the 2 key things. Knowing to start by solving this inequality, and then knowing your basic shape for the graph of cosine. And again, I like to plot these points just by dividing things in half. It's kind of like the way you slice a pizza. Draw the 2 ending points and then just cut it in half. Okay, there's my minimum. And then look at the first half, cut that in half, there's my x-intercept. Cut that second half in half, there's the other x-intercept.